Well, that was some quick recovery there by myself and Andy. Thanks for joining us today. Hi, I'm Paul Wheels. I'm the IoT North founder and orchestrator of videos today. John Staveley, the amazing organizer of the events and lifesaver of IoT North. If you want to do a show, please do email us at info@iotnorth.uk. We'd love to have you on and share with you. We've got a couple of great talks lined up in April and May. But we are always open to filling out that Rolodex. And even if we need to do a couple of shows in a month, if we get so much demand, then we're more than happy to organize it and do that. John, what have you been up to this month?
I've started a new IoT contract, which, as the previous one, turns out to be very thin wedge on the IoT front, and it tends to be like small PC running Windows that's going to sort of masquerade as an IoT device. But there is potential to use Azure IoT Hub in the future, so it's looking quite interesting. But anyway, that's my lot. I'm looking forward to seeing the digital twins talk. I've done some CAD and 3D printing in the past, and I just realized how technical getting all of those graphics and images together is. And I've been doing some research for this and watching the ISS space station demo where you can zoom in on different live data coming from the ISS, and live factories where you've got robot arms, and all robot arms are animated and they're picking up widgets, and you've got live data about how many widgets they're picking up and dropping. I was thinking this stuff looks great, but it's quite technical to come up with this. And what's the payback period? You know, in terms of all that effort creating those graphics, what can you get out of that? So I'm looking forward to hearing Andy's talk from that perspective.
Excellent. So I will go to the banner that I was just playing. Which is, I have to say that the opinions shared on this show are personal opinions and not those of the employers of the host, me, which is Intel. Andy, how are you doing, mate? How's your week been so far?
Yeah, it's been great. Thank you very much.
So, what we're talking about today, digital twins and the faux pas with them.
Yeah, absolutely. So I did a very similar talk with you guys a while back, and I wanted to reflect on some of the things that we've discovered along the way. I wanted to deep dive on some of the places where I think we go wrong as a sector and as a technology direction. And I wanted to see if I could give you my view, and hopefully some people might agree, especially John, with that sort of view around payback on 3D graphics. The important points, the important parts for actually building something of use and of value to people who want to participate in IoT-oriented, sort of data-oriented workflows and workloads. I wanted to get a bit deep into that and what is the valuable part of those in the ecosystem.
Excellent. John, you had some questions for Andy before he gets fired away.
Just like when I'm clicking on a robot arm, can I drill down into the data that's behind that? Can it bring up reports like Power BI or something like that, rather than just being limited to what's visualized on the screen?
Yeah, and I think that there's some really interesting points around whether you even want to take people into a new application or web app to visualize things. Would you like to take people away from where they already are, trying to consume analytics and trying to build workflows that are more productive, and take them somewhere which is IoT orientated? Or do we want to take our kind of IoT data and integrate it in a data warehousing kind of scenario and have a single pane of glass in order that we can have a look at things that maybe are in 3 dimensions, things that maybe are tabular, and maybe have them interacting. So we click on this, we're interested in the health of a particular machine in a factory, and it shows you that machine to give you the context of what's nearby. Having a highly connected twin is really core. So the digital twin is meant to be the virtual representation of the physical twin being the actual machine or the factory with the machine inside of it, which is realistically connected in a very deep and meaningful way to its surroundings. It's physically connected to them. Sometimes it's got connections that are not really strictly physical, but they're maybe like Wi-Fi connections or things like that. But they're still connected. There's also connections that aren't even about sharing information, but it's about contextualization, right? So the fact that they are in the same space means that they're related. And all of those things, all those relationships should be things that we can try and then interact with from a data perspective. And the more that I come to think of a digital twin, especially a 3D representation of a digital twin, I come to the realization that the twin itself is a way of manipulating and navigating data to be able to find things that are related, that I understand that are related because they're in the same space or they're connected to the same sort of things, but that traditional software approaches, traditional data approaches would find quite hard to relate. So a machine, which might be on a database table of assets, and a room, which is in a table of spaces, and a power system in a table of power systems. Maybe those things could be connected in a schema, but as soon as you start connecting them, they become kind of rigid and it's hard to move things around. So I can very easily go, yeah, those things, that machine, that power system in that room makes perfect sense for me. But for me to be able to go to a computer system that's not specifically been designed to be queried in that direction is a big problem. So to try and make data easier to navigate, when we think about things spatially, we can build a digital twin. And that then is the point of a digital twin. It's to navigate that data that's contextualized spatially. And the only purpose of bringing in 3D is so that we can do those things, that we can navigate the data. So yeah, having every single object in 3D, if I'm going to put it on the screen, it's got to be a database record too. And when I click on it, it's going to not just give me the data for that point, it's going to kind of understand that next to that, there's 4, 5, 6, 700,000 things that I can now go and connect to next in a graph that I might go and try and navigate and traverse to find interesting and hard to predict things in that domain.
Is digital twin being adopted to the size that was being forecasted, say, five years ago, or is it?
So no. Is IoT?
But that's the honest answer, though, isn't it, Andy? I think a lot in this industry was over-egged in size of volume, maybe more than a number of industries. But then it is also an opportunity of businesses seeing that the need to invest and adopt further. Like personally, I've seen manufacturing really accelerate due to the COVID impact. They are starting to adopt IoT a lot more. And retail market really picked up last year as well. So I was just intrigued. But it seems to be like the digital twin, you need to have the infrastructure in place to be able to then collect that data to deliver the digital twin. And what I've seen, and I'd love to get your view, is I've seen the proof of concepts, proof of values starting to move into actually production. There was just POC. Hell, at one point, everybody was doing POCs, but nothing was getting beyond that point.
Yeah.
We'd start to see that adoption curve happening, which then hopefully enables that digital twin and the exciting part of really visualizing that. Are you seeing the same?
Yeah, there's definitely a lot of building blocks required. So one of the key things about navigating data is you've got to have the data to start with. Having a digital twin without having an IoT stream or some kind of contextualized stream is a little bit irrelevant. A digital twin normally is seen as being the up-to-date state of something, a little bit separate from data history, more just what its current state is now. Maybe your data history is stored somewhere else, so you can go and look at it if you really want to, but it's about the current state of it. And if you can't update the current state of it by getting like a stream through IoT sources, then you just have something which is like static data. It's like reference data. And you already have kind of a lot of ways of getting reference data. Like when you bought a machine, you can create a table that's your asset registry and put in the manufacturer info. And because it's static, it doesn't change. You have not planned to change it. So there's not a huge amount of value in building a really complicated data ecosystem around it. So you have to have something which updates it for it to be particularly valuable as something to query. And the other thing is as well, like if you're going to do things spatially, you're going to do things that are about connected data in context, then you need to be able to bring some kind of visualization, some kind of model that describes that space to the table as well on day one. And I think there's been quite a lot of use of that type of tech, CAD and things like that, for some time. But it's been sort of siloed in its own way. It's been a silo of just data that we use to do 3D printing, or just data we use architecturally to design a building. And once we've done the design, we hand it over to someone who's going to go and pour some concrete. And those guys are probably going to throw it away, or they're going to export it to PDF and work off floor plans that are in PDF, or printing out or something like that. And the data kind of gets left to the side and doesn't come with us. So we have to have a more mature kind of idea around that. And one of the things that has happened in the sector, in tech as a whole, but specifically in construction, has been that there's been a realization and an awakening that there's a lot of data that's left on the shelf in construction. And all things like smart factories start the same way, which is a model that describes the shell of a building and the power systems in the building and the fire protection systems in the building. All that stuff exists, which becomes super valuable for us to build definitions of spaces that are enclosed within buildings. But it tends to get left on the shelf because it doesn't come with us. And for some real world events, Grenfell being a huge sort of catastrophe really that happened a few years back now, one of the things that happened after the inquiry was that a new Building Safety Act was required in the UK. And that Building Safety Act has kind of emphasized that a golden thread of data needs to be maintained for all buildings that are being built. So you start with something like a floor plan and you can't throw it away. It's the duty of the owner of the building to maintain that data flow all the way through the lifetime of the building. And now if you think about what that is, a golden thread of truth, like the legislation talks about it in those terms, quite abstract and general terms, but what they're really talking about is a digital twin, something which is a data representation of the building that's kept up to date, maintained, and matures with the building, such that it's useful for things that happen regarding the building. And that's really, these days, it's always going to be data orientated.
Yeah. Excellent. Do you want to do your review as you described it earlier?
Yeah, sure. I will hit the present button and then see what happens. Okay, I'm going to share screen. Right, I'm going to share my whole screen. Hopefully that is working. Can you see yourselves? Oh, wow.
See ourselves now. Oh.
Well, I can see into the future. Let's go.
I'll remove it till you've got it ready. There we go.
Right, you got that?
Yeah.
Okay, great. Let's hide that little pop-up. Okie dokie. So the talk, Fixing a Broken IoT with a Digital Twin. The core idea then of the original talk is that IoT doesn't work particularly well for the sole reason that we build out silos between our data, and those silos between our data cause our systems to be complex and difficult to maintain and to navigate. What I'm trying to go through is call out where I was right and where I was wrong with those talks, and go through some of the things that happened at the same time that allows us to sort of learn from the progress of tech as a whole. So it's been 2 years, the market has shifted. One of the biggest things is actually moving away from the hype cycle of the metaverse, and digital twins are associated with the metaverse. What metaverse is, it's difficult to pin down. What digital twins are, again, difficult to pin down. These are terms that are prevalent in technology, but actually were really designed for media and mass consumption to describe technical concepts and technical solutions to the mass market. And what's happening right now is this is one of the first times ever where something which is societal scale, like Facebook, has decided that there should be a new way of communicating between people. And it hasn't been replacing nothing or an incremental change for a very small number of users that goes viral and gets mass adoption. Instead, this is something already at mass scale, at societal scale, that's attempting to change fundamentally its approach and is trying to introduce a new technology to a mass user base. The metaverse then is an attempt at a seismic shift within a single segment of people, and not one that's gone particularly well. Digital twins, I would say, are fundamentally different from the metaverse. I'd say that digital twins are a representation of an asset, and a representation of the way a company or some entity operates. It's a process plus state plus asset reference data kind of environment. But it has been used, the digital twin and the metaverse have been kind of linked, particularly around the requirements for 3D graphics and 3D representations of stuff. I think they're fundamentally different. I think the metaverse is a 3-dimensional social media experiment. And I think the digital twin is the next phase of managing and modeling data regarding spatially integrated assets. I think that both of those terms overpromise a huge amount, and the market has shifted away from it, which is why we've seen quite a lot of stuff. So the original question was just, what's a digital twin? One of the questions 2 years ago that we didn't know we should have been asking, but we should, was, describing that as a good team to get sacked from, right? A digital twin team, they have not been particularly successful. If you look across metaverse applications, if you look across the myriad of startups in that space, if you look across what Microsoft have been doing, across what Amazon have been doing, and the people who have been retaining their jobs and the people who have been losing their jobs, you'll find that a lot of this stuff associated with 3 dimensions, a lot of this stuff associated with putting new types of interfaces over the top of this type of data have not done well in the recent readjustments of technology teams. Now, those technology readjustments were actually broadly in relation to the overhiring during COVID, the sort of need for companies to show growth in a difficult time, the need for them to find a way to supplement the headcount of their company so that they could move into a new technology space, double down on something like Teams. It caused everything to get a much larger footprint. And there's been a natural sort of paring back of that. But the paring back has come down hard on metaverse and digital twins. If you look at stuff like layoffs tracker, you'll see January, for example, almost 125,000 people laid off across the tech sector. You see this has happened primarily in the last quarter. The last year has not been particularly good for us in our sector. You can look at how the majority of those people have been let off by some very, very large companies. This doesn't even have Microsoft on there, who let go another 12,000 or something in January. So there's a large number of people who have been laid off, and a lot of them have been around this particular space. Now, does that mean it's all doom and gloom? No, it doesn't mean it's all doom and gloom at all. It means what we should do is just take a step back and look at what's good and what's not. There's been a huge amount of pressure and push to have things like Microsoft Mesh, to have things like 3D working, remote work where you're virtually located, despite the fact you're not physically located, a digital twin for communication and collaboration. And those things have simply not worked. If you look at the videos, I can distribute this afterwards. You can look at lots of stuff on Microsoft's website. You can look at lots of stuff in the sector. You will find people like Accenture putting loads and loads and loads of money into programs where they try and digitize onboarding, digitize work. And they simply haven't worked. They are projects that everyone's pulling back from. That it's very confusing to see how anyone would actually want to have these kind of interactions when you could have normal interactions. And it's one of those scenarios where it's hard to see what the 3 dimensions is actually adding in terms of the payoff, as John was saying earlier. What's the payoff for this? We have to spend all this money to model our entire environments. Why? We're building a virtual representation of our space. We're going to put windows in. Why are we putting the effort in to put windows and walls into our virtual space? There's no weather in virtual space. There's not a lot of joined up thinking around what it is and how we actually get value out of it. And there are some very good bits. One of the reasons I kept this particular video in is that Accenture go through a lot of really value questionable parts in their first section, and they get towards the end and they're sort of tailing off and it's getting a little less hypey, and they start showing like mechanical devices that people can look at and understand the specs for, and they can engage with them, and it starts to actually make sense as to why that might be an integrated way where you collaborate around something that's also digital but in 3D, why that might make sense. But before that, it's just a lot of people wandering around with silly haircuts in a virtual environment playing, where no one's really looking for any outcome or any benefit or any kind of actual win from the scenario. So that is definitely my personal opinion about where we have gone and the sort of thing that we might want to pull back from. If we come up with a slightly new definition of a digital twin, I would say primarily it is a spatial representation of data or representation of spatial data that provides users with useful tools. It makes a huge amount of sense when we think about things that are spatial, and we use our human brains to understand things. We're in a room, we have assets like TVs, we have assets like chairs and desks, and we have lights, and we have temperature sensors, and we have air quality sensors, and we've got water flow sensors, and all these things are related here, and they all live in different databases. So bringing those things together, but maintaining the spatial impact of those things so that we can link them together, 100% what we should be doing.
Andy, can I just touch on that side of things in regards to the metaverse side? And sure. I've seen a couple of other companies talking about this recently. In that, I'm still for the metaverse, like you were talking about the HR example, and people meeting inside of things. I'm trying to understand if there is any psychology reports or anything that say that there is clear value in creating this environment where you have these avatars rather than a Teams conversation with your cameras turned on, because the cost and impact can certainly make it decisions quite easy, because it's not that quick and easy to make those metaverse. However, saying that, I will eat my words, because I have seen a avatar created from your face in Teams, as a beta thing that I got a glimpse of, which was really interesting. It's literally turn your camera on, it turns you into an avatar, and it talks. And the scary thing was your expression was based on the tone of your voice. So sarcasm may create some interesting facial expressions. But I'm really, are you aware of any reports that demonstrate that psychology view and value?
I've seen reports that talk about the success of metaverse experiments being highly related to the immersion you can achieve through wide-scale adoption within a cohort. So it only works when everybody's using it. And I've seen that the same report postulates that you can't have some people in a mixed mode. So some people cartoony, some people with a video, because it breaks immersion. And I haven't seen much around I see quite a bit around the impacts of remote working health, especially after the pandemic. Quite a lot of feedbacks on that. But on the metaverse, not specifically. I mean, what would your view on that be?
Well, I just find it really interesting. Like, I know from my team that I work with and others, customers, partners, and like that, there is definitely a want to get out to be more in person in events and socializing in person a lot more. The whole home working thing, everybody's overworked, and there's an awful lot of burnout happening. That then stepping into a metaverse, and especially if you're using headset and such like, then that's even more strain on you. I mean, I was a sucker straight away. I got an Oculus headset. It's probably been used about 15 times, but it's because after like 30 minutes, it is a better experience than PlayStation. PlayStation, I could last 25 minutes. I can last an hour with the headset on, and then it starts to become a bit of a irritation having something hanging off the front of my face, to be quite honest. But then, like, from a working environment, and if you think about how you go from meeting to meeting to meeting to meeting these days, and wearing a headset and the like, then it starts to put a bit of a strain on you physically as well as mentally as well. And I find it really interesting in COVID, the first 6 months, 9 months, everybody had their cameras on. And I've seen this trend personally where over the past 6 months or so, like, less people are putting cameras on their Teams conversations and the like. They're preferring to just stay anonymous and just hear and be able to be heard and to hear.
Yeah. Replacing that with what the computer thinks your tone of voice is, I think brings in just a whole extra set of problems.
Yeah,
but I think that there's definitely something in that this is a fundamentally different time. I don't think we'll understand our time for another few years. I think we'll need to have a little bit more reflection on the things that we've all been through over the last 3 or 4 years. And I don't know whether throwing technology into the mix straight away comes out with a good outcome. And I'm saying that as a massive technologist.
Yeah. Well, I think it's that thing. And I mean, like, I remember, hearing about digital twin a long time ago. And the examples were, as you were saying, that in spatial data, the environment, there was a vision. I worked on an IoT project with an energy company, and they were talking about, they had the data from each machine, and even from the amount of energy use that was going on, they knew a compressor was faulty over there because there was too much energy being used. So then they could visualize that, and they were talking about even creating that digital twin experience of being able to hold up an iPad with AR rather than VR. That everything's popping up. I believe PTC, PTC Works, is it? They acquired a company that enabled that connection between AR and your data drive to enable that digital twin and that kind of perspective. Those types of use cases, I think, are really, really interesting. That, imagine that senior leader of a business being able to see how the factory's running, as an example, and seeing the efficiencies and where there are gaps, and being able to tap into that by being very visual, and also knowing that, I know this person will be at that area of the floor, drop them a message to say, hey, look, we've got a problem coming along here, and making them feel like they're part of that day-to-day when they are remote. And also, that experience of starting to head towards automation and autonomy by creating that spatial environment and virtual environment that way, that, if we do have a COVID impact and you've got to pull people off the floor due to that type of issue and environment, that actually you can be remotely monitoring and only sending people in when they need to be there, because you've got that automation autonomy running,
Yeah, I think all those things are about processes and spaces as assets that make sense for us to provide tools over spatial data. I don't think that is at all what was happening with the core metaverse. I think you're describing quite well the definition or the distinction between social aspects of a metaverse and the useful impacts of a digital twin.
Yeah, I mean, let's be honest. In the metaverse, what all everybody's want to do is going to slap each other with a stick.
It's absolutely I've got a new skin. Look at me for 15 minutes.
the virtual bullying.
Yeah, absolutely.
Sorry, I digress. Please do continue.
Okay, so let's think about that in terms of how we then go and build something. Okay, so we have data that we would regard as related to facilities, data regarding operation. So this might be sort of the state of the boiler, the temperature, the number of people who come through, the amount of energy that's being used, might come through the utilities route. It might update a digital twin. To build that thing, we're going to need to bring in data that's like floor plans and the makeup of a particular building. That is broadly building information models. They are what you create. If you're an architect, if you're a construction company, you make a BIM file. You use something, some of the industry leaders, or people like Autodesk with Revit, collaboration. Their collaboration tool is Navisworks. Those kind of things are large players in that space, in the building information modeling space. You combine that with asset registries, so you know who owns something and when it was maintained. And here you've got data which is somewhat static, data which can be updated a little bit more frequently, but is broadly static in your ERP. You've got data which comes in at real time, but you don't really own it that directly. If it's the amount of energy that you've used and it's the report from your utility company, you kind of don't really own that part of the data, if you know what I mean. You don't really measure it yourself. But then you have stuff around your facilities, which could be from like your factory, or it could be from an office space or whatever. Any of that space, broadly, the current state of that building, we should update as fast as you can. So you get the utility operation stuff tends to be maybe every day, maybe every hour. You might have current temperature being measured every minute. You might have your asset registry being updated every 6 months when you change the battery in a particular device or something. And your BIM file, maybe you make it once at the start, and then maybe when you remodel the building in 5 years' time, you update it and you push the information back into your digital twin. So with all of these parts, then you've got real-time data, you've got static data, and they're coming together to describe it. And quite importantly, that BIM file element allows us to create a version of a representation of space that's accurate to the designer and the constructor. And if we take the Building Safety Act in the UK and the similar ones around the world, with the requirement to try and keep data in line and up to date throughout the useful life of a building, then what we've got then is a requirement that says keep that BIM file up to date. So every time you remodel it, you should update it. You shouldn't let it get out of date. But you can also achieve that through combining all of these to give us some over histories which update the BIM file to give us another representation of that data that comes together to give us a good outcome here, which is the digital twin. So from a pure data perspective, bringing these things together gives us spatial information, asset information, and then utilization information and state information. And it brings it all together to give us a good current view of where we are. Storing every change to that behind the scenes gives us a history or a sum over histories of all the things that happen to get us to where we are, so we can provide analytics underneath that as a platform. So if we're going to go and think about the type of things we want to actually do with a digital twin, right, we are going to need to know how a building owned and operated by our company, used by somebody else to host an office space, how are they actually using that space? How are they using that factory? Using IoT sensors and data streams we've got. How do we do that? How has it changed? I've spoken about COVID already, but what pattern of use is changing over time? And what happens inside the building on days when we have a poor yield of the widget maker? Like, is it high humidity when that sort of thing happens? Is it just because there are more people coming through the door? Is it because there's something else happening within the life cycle of the building that we can understand because of the overall context? And how might we prevent failures? By getting ahead of that, looking over some of the histories and the current state of something to project forward, not just to look now and backwards, but forwards as well. We've kind of skipped a couple of questions in the previous iteration of this, which is how do we populate that twin? How is it maintained? How is it linked to other systems? And how do we contextualize? How do we have both data to contextualize it and definitions of how to contextualize it? How do we actually understand the silos that we're about to make? And if we talk about silos, then let's just go through some of those. Rooms and employees define how a space might well be used. Occupancy is the natural next step of that. Temperature, electricity, these are sort of consumables that maybe live in that space, but it leads us towards a smart factory kind of route. And then you might have other assets regarding the building around its maintenance, who's using lifts and the state of lights. You can find some of this data in BIM files. Some of it is in a staff directory. You've got some of that more based on aggregation of activity, probably IoT sourced activity. This sort of telemetry here around temperature and electricity is 100% the sort of stuff you get from devices. And then asset registries here for maintenance and for smart lighting kind of tech. Now, we have all those different data points coming through. They often, and this is the original talk, broken IoT, what would that mean? Broken IoT was the existence of silos. When things come through and we have our own databases for every type of sensor, it's exceptionally difficult for us to pull that data out in real time and integrate it such that we can say that across these vendors, across time, this is the reason that something happened. We end up investing a lot of money into integration workload challenges and less into actually modeling our space and less into actually building out our IoT environment. So how do we achieve those things? How do we break it down? The point is a digital twin to ask questions like how, when we set the temperature on a particular floor, how does it set the thermostat settings across the whole building? How does it affect that? How do we work out how many people are in there based on the telemetry coming through from a burglar alarm system? And then what is the power demand when there's people in the building? We're earning more than £50,000 is a bit of a joke because we have therefore multiple different systems come together to make that a really difficult problem. But these types of questions where we're saying, how do we relate things spatially, and not just spatially physically, but like using relationships to other systems? How do we try and pull data together that's highly correlated and highly related in the real world? How do we get it in a system where we can query for it? And it kind of comes back to that point that it only makes sense to do this if the data is related in that kind of spatial way. If you can kind of go, well, tell me about the people in this room, or tell me about who's next door, the state of the machine just down the road, the power system in the switch that's next to it, the people underneath us, the water flow upstream. That is absolutely spatial data, and it allows us to do all kinds of different interfaces. But spatial data is not just avatars. It's not really, we're not talking the same thing. To be successful with digital twins, we're about using data spatially. And here's an example, and I'll show you this really quick. As a simple example, right? Imagine we've got a building. It's a simple building, and inside here we've got a number of radiators. We have a number of workstations. If we're inside Power BI and we want to click on something like just show me the HVAC units, what we're expecting to see is the workstations disappear and for it to zoom into one of those. If we click on one of these, we expect to know a little bit more information about that. Now, I'm going to Alt Tab, and hopefully you guys will follow me. Are you guys following me? Shout out if that didn't Alt Tab, somebody, please. So here we are inside a Power BI application here using one of our custom visuals. And inside this custom visual, which is a 3D representation of space, we have got the ability to model assets inside here. It gives us some information when we hover over it. This is a HVAC radiator. This is a workstation over here. And it allows us to sort of say, right, I'm only interested in HVAC, or I'm only interested in workstations. And this kind of thing where we're actually contextualizing space and we're trying to understand what's happening in there based on data, but empowering people to do it by just dragging their data from Power BI onto a visual and connecting it up so you can understand what's going on with temperature, energy use, things like that, in a tool that we already own and we're already in. This is where a digital twin starts to break out its value from a core app and starts to add a huge amount more value. But to do this, then how do we get our 3D visual? How do we get understanding of all the assets that's in there? Well, I'm going to go over to a different screen here, and we will see something running in Visual Studio Code. Visual Studio Code, a free IDE. And inside here, you can see a Blazor application, which is a core version of Intelligent Spaces running locally on my machine. And you can see it's emitting a bunch of stuff. I'll just copy one of these, and then I'll go back to this window here. So inside this window, we can go through, we can see a list of things that are deployed to my local Intelligent Spaces instance. I can go through and I can look at a file that I brought in from a BIM file. And then during the process of bringing it in, I've modeled it into a definition of a digital twin. In that definition of digital twin, there will be a lot of different things that describe this building down here. This building down here, if I load into it, is part of the building that you saw in Power BI. There will be assets inside here as it loads up, including workstations, including walls, including light fittings, including sensors. It tells us things about the sensors that are in there. It gives us information about the last time data was seen. We can go and click through, look for workstations. We can drill through and find out information about our workstations that are there. We can do all kinds of interesting things like that. Now, when I was showing you that, we saw a whole bunch of stuff written into the console. I'm just going to grab one or two of those things. We'll go back to Digital Twin Explorer and paste in the first one I got copied, which is just looking for assets inside a particular building. We ask Microsoft to go and give us that, and it immediately says that inside this particular building, this level, we have got entrances, we've got assets, and those assets have got the capabilities of being sensors. Here, this is a particular item which can detect whether or not there's motion detected, whether there's voltage. We can go into this one. We can see this is number of channels, the live voltage on this one. This one is an air sensor. You can see here we've got CO2 readings. A little bit blank, but this is a local environment. But you can see we basically asked Azure here, Azure Digital Twins database, what it knows about levels, rooms and assets, and it gave us a graph back. Now these graphs are the things that allow us to then really traverse meaning inside space. We can get relationships. We can see what relationships are on this particular this is a level I think I clicked on here. You can see that it's part of other assets, and these are the things that it relates to, other levels here. And we can traverse and navigate around our digital twin here through a thing. But the real fun is to try and traverse it graphically. So doing that then is taking a BIM file through, and every single thing you can see here with the mouse hover over it is an asset in a database. It's something that's connected to the digital twin. We do that automatically by letting you upload a BIM file, pushing it through a mapping sequence that then makes one of these digital twin databases. That digital twin you can then update with IoT telemetry, and that's how we end up getting the telemetry available inside the app as well. We do a whole bunch of stuff around the data platform. So in our analytics pack, realize I'm still on my local host, so this is definitely finger in the air. Wow, there's so much stuff in my local version. Oh, let's go with this one, see if this works. Looking for any temperature readings over the last 7 days based on the sensor ID. Forecasting forward that. I don't know where that will work. Oh, it did work. It did work. Red being my terrible stylistic choice here. You can white label the colors, and I chose red. Why? I don't know why. But here you've got it forecasting forward sensor readings of temperatures using a line fit CO2 into the next 7 days. So we've projected forwards with a digital twin here as well. Okay, let's go back. So what I then have shown is taking data from a BIM file, connecting it through a digital twin, connecting IoT data to it, and also bursting it out into a Power BI instance that allows us to actually engage and use analytics where our users are, right? Not taking them out of Power BI to our app. Yeah, sure, you can do that. But when they're in our app, we can say, hey, would you like to take this visual and put it inside your Power BI? Because then you can start engaging with it along other data that you've got in your enterprise in the tool that you already know. So that kind of interaction between Power BI and the digital twin and the related kind of IoT telemetry coming through, I think is super powerful and one of the best parts of a digital twin solution. This is then the really core idea that we've got and our Intelligent Spaces app, what it builds, data from the real time and data feeds onto that graph database, which was the Azure digital twins that I showed you in the portal. We build that graph database. I mean, it starts off empty, of course. How do you go and model it? We build it from the 3D floor plans or 2D floor plans, BIM data, which comes in and generates that digital twin database, that really strong definition of space that then gets combined with telemetry from sensors and data streams to build cloud-based telemetry and give users a way of understanding it. In Power BI, we do things in Teams, we do things on our own web app, we do things in all kinds of different spaces. But that kind of combination then between twin databases, twin tech, Power BI gives a holistic and sort of 360 view of contextualizing data regarding spatial information and putting it all together. Keeping that stuff in sync is something that we're working super hard on. We're very strong already on, but with the Building Safety Act coming out and that need to have up-to-date data, we think the digital twin ultimately becomes the Building Safety Act thing. It becomes the thing that you trust most of all. It's your source of truth that you go to for information about your building. And we also want to be able to keep the BIM files and related assets up to date such that data that was the original generator doesn't also become obsolete in the process. So we try and update that every time something happens on the twin, not necessarily every piece of telemetry, because that doesn't really belong on the BIM file. But if you go in there and rename a room, you change the definition of one of the plumbing systems, you change an asset in an asset registry, that should flow back to the 3D model and have it read-write rather than read-only. Without that definition of space, none of this works. You can't actually hook anything together and contextualize anything without that definition of space. So the BIM file or some form of definition of space is super, super important. If you don't have that, you don't have this. I think one thing that we've learned is that the overlap, I think we mentioned this right at the start, about the sort of things you need to come to the table with in order to make a digital twin work well. Some definition of space, I called it BIM here because that's always where my brain is at. But actually, it's any definition of space. It could be a model that you do in a standard modeling tool. It could be in a different type of 3D SketchUp kind of authoring engine. It's something that defines and describes space really, really well and lets you tag assets and meshes and instances of meshes inside that file to allow you to kind of connect up with streams of data coming through, which come through via maybe a metadata service. But the intersection of those things is where you can build a super powerful digital twin. The number of people who have both in the market is small, but it's a small but growing segment. The number of people who have got BIM files is increasing. Legislation out there saying you've got to maintain this sort of information is pushing up the number of people doing it. The sort of need to optimize and cost optimize is pushing people forward in IoT, and therefore they're both growing sectors. That means that intersection in this little Venn diagram is growing as well. That makes it a growth sector. So when I go back to that initial statement of it's a great team to get sacked from, I don't think that's necessarily true. I think it got there was a point in time where it got very hypey and wasn't able to achieve the things that people were promising. But as I've shown, like, we can do those things. They are possible. We can have spatial data. We can have real-time telemetry. We can have integrated with analytics, integrated with BI tools. We can do a 360 of data. So that means that because it's no longer really that hypey, it's now a capability that we have in the sector. I think this is primed once again to grow and to explode as a space. One last thing I wanted to talk about, I can't really get through a talk without explaining what happens to that data when it comes out of those models. We have this problem, I guess you'd say, which is if the digital twin database, the Azure digital twin database, is an empty database, a capability that Microsoft offer, and you've got a BIM file, how do you take the data that's in your BIM file, which is sort of geometry with tags, kind of, how do you get that and make it into something which is a database that you can hook IoT information on the back of? I think that's like really, really, really cool. So our approach is an automated mapper. But even if you wanted to do it manually, you'd still need to be able to describe the data like in an effective way. So just like in traditional systems, like SQL databases, those kind of things, a relational data structure, a document store, most things coalesce around known and understood shapes for things. And naturally that, even in semi-structured kind of domains, semi-structured and structured share the fact that they're structured from the point of view of the thing that needs to read them and the thing that needs to write them. They might not always have all the information in some circumstances, but the things writing understand the bits that they need to understand. So you can't have something fully unstructured, but we need to come up with a way then of taking something and building a twin, which could be of anything, but have it in a consistent shape from the point of view of the things that need to rewrite it. So how do we do that? The database starts empty. We've got a BIM file. It's like an Excel spreadsheet of name values in random shapes, sometimes nested children of objects. And each of those Excel tables or worksheets is associated with 3D mesh, effectively, that allows us to say this is a chair and it was made by this people and it's made of this material and it's this high and those sort of things. All that information for every asset in different shapes lives right there on the mesh. So how do we do something with that? Well, given that we need to come up with a common way of describing shapes, there is a way to describe buildings particularly, but other objects as well. And it's a common data model. And that's kind of an agnostic way of structuring data that we can all agree on. It doesn't really relate to format, more the structure of stuff. It's like the links between things, and it talks about generic problems. And it helps us build things that are compatible with each other, because we agree not on the data format so much, but more the structure of it. The difference between one of those being a format is a text file, a format is a Parquet file, a Navisworks file. That's a format, but the structure is I've got this data point with this and this and this, and I've got this data point with this and this and this, and they kind of relate to each other like here and here. One of them, for example, a room, I've got a name and I've got a size, and I've got a chair, and the chair is inside the room. That's two pieces, there's two data structures that relate to each other, and nothing describes that as being in a text file or a CSV or an Excel spreadsheet or whatever. We describe the data structure, not the data format. Anything that understands that data structure then allows us to really work as an ecosystem together, to rewrite it together. Allows us to do things really quickly with a strong agreement on shape. So the thing that we do that with inside Azure Digital Twins is firstly Digital Twin Definition Language, DDTL, which is a description of data structures that allows you to create ontologies. It's a bit of a complicated name for what is effectively a schema. From relational databases, it is subtly different, but it is effectively how things are as shapes of data and how they relate to other things that are shapes of data. Real estate core is an implementation of digital twin definition language, DDTL, and it gives you the shape of things that work really well inside real estate. That is a real estate having a building, buildings having levels, levels having rooms, rooms having assets, assets having sensors, there being agents who look after things, assets having capabilities, spaces having rooms being a type of space, spaces having tenants. The types of things that I'm describing there, and the relationships between them, are the things that are described by Real Estate Core. It's now version 4. It's been version, well, I was going to say version 3 before that. That's almost self-explanatory. But there is a new version out there at the moment. And I would suggest that people who are interested in getting into this space would look at how you build one of these Real Estate Core engines. It's open source. It's published by Microsoft. The Real Estate Core is like a consortium, and they're made of architects and planners and people who make buildings and manage buildings, and they publish in conjunction with Microsoft a digital twin definition languages, and we use that and we extend things to give exactly the type of thing that you saw before, which is the 3D representation of it. Creating it from scratch, going back to why we use BIM files, it's super hard to actually fill in and create one of these ontologies. You get the shape from the digital twin definition language. That's effectively getting the table structure, the number of columns and the types of data that's in those columns. But then filling them in, as in entering them, is pretty tough. There isn't really a standard input tool, and it's a bunch of REST APIs that you have to write software really to do. Convert data you've already got is my number one takeaway from that space, and it remains it to this day. So in an end-to-end then, how do we build and how do we fix broken IoT with a digital twin? We take data that represents the initial state, the reference state of a space, and we push it into a system that can extract and crack those proprietary document formats. Those document formats are made by a handful of really, really big vendors. We work with a lot of them, pull the data out of them, push it into an Azure blob store so that we can do stuff with it on a data lake. We call that our BIM store. We provide some APIs over the top of it, not so important. We take the data that's inside the BIM store, push it onto a digital twin going through a mapping tier of a YAML file. We connect via a metadata layer IoT data onto the digital twin. The digital twin writes its data out as a history to Azure Data Explorer, or Custo to its friends. And that gives us a history of all the events we ever saw. So the twin stores the current state and it passes the previous state and the new state across to Custo. We take the geometries that are inside those BIM files and we push those things out. We convert them into something that's standardized for the web. We distribute it on the CDN. We build a web app over the top of it, a Teams app, mixed reality apps, Power BI should be on there as well. And we allow people to interact with that as a digital twin. So that, in a nutshell, is our solution to fixing IoT with a digital twin. It's focusing on the data. Everything you see in 3D should be a database record. Everything should be interactable. You should have a common data layer underneath it that allows you to interact with your analytics from multiple different sources, from BI tools to data science tools. You should be able to build in histories and predictions. You should be able to build 3D stuff inside a web browser. You should also be able to push it out to other environments. You should be able to mix reality up by understanding the space really, really, really deeply and combining that with states being passed over the wire. So how would we answer those earlier questions? Use an ontology, combine it with BIM data and real-time analytics to work out how space is used. Use the data factory, the data platform on Azure to actually provide historic analytics, other cloud vendors exist, to provide historic analytics and spatial data, break down those silos to understand how everything is affecting the initial machine, the widget maker, and use predictive analytics and forecasting tech inside that data platform that you get from the cloud vendor to do that kind of preventative maintenance kind of workloads that are in there. Ultimately, building something better over time is about democratizing access to these. These things become a base load that other things get built on top of, integrating more metrics, understanding space even better, and then effectively pushing data that we've got to some really interesting new spaces like carbon accounting and things like that, to really come up with solutions built on top of this new digital twin that were actually really tough to do before because they required us to do too much manual work to bring information from too many sources, and it all sits together on our digital twin. So that's really the direction that we end up going. And with that, roughly at the hour mark, I will pause for any questions or any feedback from the hosts. Thank you very much.
I had a couple of quick questions. Appreciate we're lacking on time. BIM file, building information model?
That's right.
You may have said it, I missed it. And
Yeah.
What's running on localhost 5000? Looks really cool and bespoke.
So that is, it's Intelligent Spaces. Go and have a look at intelligentspaces.io. It runs locally on my machine. When I'm doing demos and want to show how the output gives us the digital twin query language.
Right, so that's not something that we can do easily then.
We don't. Not so much.
How much of it is real estate core? I wasn't clear on that point.
Real estate core is just the data shape inside Azure Digital Twins, and it gives you a schema effectively to work from.
So that gives you the floor plans.
Yeah, effectively. Yeah, it gives you the data behind the floor plans.
Okay, so you've created something on top of that to visualize it, or is that what you get?
Yeah, to generate if you get the schema, actually creating the rows comes out of our system, and also then tying the geometries to it as part of the flow.
Right. Okay. There are plenty of questions in the chat.
Okay. Should we have a look?
So we've got John Hardy. John, thanks for being patient with this question he asked very early on. What do you think is missing in terms of tooling to make digital twins the default rather than the norm? Are they always going to be domain specific?
Yeah. So I actually see that there's multiple types of digital twins, and there's not multiple types of tooling. The tooling tends to be pretty domain specific, but the twins that you can get out there are either asset orientated or process orientated, and process orientated verges on simulation kind of tech and the ability to say, if these things are connected, what happens if what if scenarios in a process is super interesting, and I think that's absolutely missing. I think a lot of tech is being done around simulation, but doesn't go anywhere near digital twins. And I think that the nature of it is that you would need to simulate similar types of things, like a water flow domain would go to a water flow ontology, a water flow twin. But as you can see, Microsoft has tried to make a database, a digital twin database, which is generic and sort of horizontally targeted. So I think that you could say that there are multiple different types of ontology that describe water flow. And if you can get a simulation engine to work with that kind of process ontology, you'd be able to crack a huge market.
Excellent. Thanks for that. David, thank you for your question. We call software models of physical hardware digital twins, I assume mainly because it sounds sexier than simulators. These are used for two main purposes. Firstly, to verify design before tape out, and to test application code in the absence of expensive hardware. Not sure if that's a question or a statement. Does it sound sexier?
I don't know. They always talk about a digital twin being the digital representation.
I mean, flight of the digital twins or flight of the simulator?
Well, there you go. I think that's a good question. Well, a good statement. And I think that underneath that statement is a sort of a question saying, could digital twins augment or replace simulators? In the end, I think that's just like I said on the last answer, those things will get merged together a lot.
Yeah.
And I think that the digital twins will do a bit of both of those solutions.
Another one from John. What do you think of interactive spatial query languages, e.g. search? You can see on your screen, I think. I'm not even going to read all that out. Do you think low-code, no-code tools will win?
I think that spatial query languages help, but if you're good enough to write a query language, the spatial query language doesn't bring a lot, because the second question is the answer to that is a yes for me. So because we are moving so much towards low code, no code, the abstractions and domain specific languages around spatial search kind of, they still lead you to a high code scenario. Yeah. And putting a UI over the top of it takes it to places that you can't get to with that.
Excellent. And we have another one from John. Do you mark data as more or less likely to be invalid? For example, placement of walls is more reliable than placement of desktops, like a spatially rendered attrition probability.
Do you know what? That's a really interesting question. When we're working with Revit files, we tend to treat all the data in there as equally correct. And when we work with Navisworks files, which are a collaboration format, Navisworks files have like effectively layers in them, and you'll have like one layer which is the architecture, and then one layer will be like the piping and the fire suppression system and electricity, things like that. Those ones we treat with different levels of accuracy, and we flag things as the likely cause of things like clashes that we can pull out of Navisworks, because people tend to put loads of effort into architectural columns and fire suppression systems that are safety critical and used by people to do the sort of calculations on stability. However, when people are doing the furniture layers and they're putting the sofas in and the fit out of the kitchen and the canteen, and whether or not they're putting like plant pots on top of desks at the reception desk, they put a little bit less effort because those are a little bit aesthetic. So yeah, we flag a few things like that.
Excellent. Well, I think we're going to have to wrap up now. We have overrun slightly tonight. We have, I'm just making sure I've got the image to show, John, because I wasn't prepared with the video at night, was it? Let's be honest. But we have a great talk. Is that next month, OpenVINO?
Yes, that is definitely the next one. Look forward to seeing you all then.
And that's 4th of April, 6 p.m. We have Adrian, who's part of the OpenVINO team, and he's going to be talking about a few lines of code for faster real-time inference. Yeah, that should be a great show. We'll have the running on the webinar, LinkedIn, YouTube, and Twitter. I think Twitter worked tonight. It's been a bit faulty for the past couple of streams we've done, but it looks like it's been pretty steady tonight. Thank you, everybody, for contributing, and for Mr. Hardy for all his questions, as always. John, keep firing them in when we're doing our shows. It's really appreciated. And of course, Andy, thank you very much for that talk. It was absolutely brilliant. I love the conversation, and look forward to next year when it's telling us how much it's advanced and actually really making. And you're presenting in your mansion with your massive screen behind you rather than at the side. Thanks very much, and good night. He says, stalling while he looks for the video he made after 3 seconds.